Hello and welcome students. My name is Dr. Vibha Shrivastava and today I am going to discuss about oxidation states. It is important to know if an atom loses or gains electrons when combining with other atoms to form compounds. So how do we keep track of the electron lost or gained by an atom? We do this by looking at an atom oxidation number. So oxidation state or oxidation number are numerical values that are assigned to atoms during oxidation reduction reactions to help us keep track of the transfer of electrons across different atoms. So what is oxidation number or oxidation state? It is the formal charge on an atom in a compound or an ion is called oxidation state. It may be defined as the number of charges an atom would have in a molecule or ion if electrons were transferred completely. An increase in the oxidation state indicates that an atom has lost electron, therefore oxidized. A decrease in the oxidation state indicates that an atom has gained electron and therefore reduced. For example, see in this reaction, zinc as a reactant has 0 oxidation state and in product it has +2 oxidation state. That means oxidation state of zinc changed 0 to +2. That means here zinc is oxidized form. And in reactant we have see copper has +2 oxidation state, but in the product copper is with 0 oxidation state. That means copper reduced. Its oxidation state changed to +2 to 0. Here we can see the oxidation numbers in periodic table. The number at the top of each column is the most common oxidation numbers of the element in that group. Like this, +1, +2, +3, +4, 3 minus, 2 minus, 1 minus, and this is 0 for inert gases. And there are many elements shows variable oxidation states due to very small energy difference between N-1d and NH subshell electrons, because here both the subshell take part in bonding N-1d and NH subshells electrons. So here we can see manganese has higher oxidation state. Now rules for assigning oxidation number. First rule, the oxidation state of an element in free state is always 0, like bromine, sodium, hydrogen. These are in free state with 0 oxidation state. In a compound, the more electronegative elements are assigned negative oxidation state and less electronegative elements are assigned the positive oxidation state. Here fluorine is more positive than chlorine, and in HCl chlorine is more electronegative than hydrogen. So that more electronegative atom assigned with my negative oxidation state and less electronegative element has positive oxidation state. In a neutral species, the sum of oxidation number is 0. N2O. Here 2N with +1 oxidation state and oxygen is electronegative with -2 oxidation state. So these are the neutral species and sum of oxidation number is 0. In HBr, hydrogen with +1 oxidation state and bromine with -1 oxidation state. Here sulfur with +4 oxidation state and oxygen O2 has -2 oxidation state. So sum of oxidation number is 0. Fourth rule, the oxidation number of oxygen in most of its compound is 2-. Here we can see the compounds oxygen with -2 oxidation state. Now fifth rule, the oxidation number of hydrogen when combined with non-metal is +1. Here hydrogen is combined with non-metal. Hydrogen with +1 oxidation state in methane, in ammonia, hydrogen with +1 oxidation state, in hydrogen fluoride, hydrogen with +1 oxidation state. And when combined with metal of lower electronegativity, oxidation number of hydrogen is 1-. Here NaH, hydrogen with -1 oxidation state, CaH2, hydrogen with -1 oxidation state, and KH, potassium hydride. Here hydrogen with -1 oxidation state. Rule 6. The oxidation number of fluorine in its compound is always -1. 1- or -1 is the same thing because it is the most electronegative element and cannot form more than one bond. Here we can see OF2. Here fluorine with -1 oxidation state. Sulfur hexafluoride, fluorine with -1 oxidation state. ClF, fluorine with -1 oxidation state. The oxidation number of fluorine in its compound is always 1- because it is the most electronegative element and cannot form more than one bond. Now the oxidation number of other halogens in binary compounds is usually -1. KBr, bromine with -1, NaCl, Cl with -1, MgCl2, Cl with -1 oxidation state. Now seventh rule. Group first, second and third elements of the periodic table shows oxidation state of 1+, 2+, 3+ respectively. Like this, KBr +1, CaF2, calcium with +2, AlBr3, aluminium with +3 oxidation state. Potassium in group 1, calcium in group 2, and aluminium in group 3rd. So these have +1, +2, +3 oxidation states respectively.